Guys, am I audible? Okay, that's good. Okay, good. Okay, guys, so let's start. So yesterday we have discussed about the basics of OSI model and about TCP/IP stack. Okay, TCP/IP stack. Overall and very basic things we have already discussed. Actually, how many layers are there? Okay, what is about L7, L6, L5, L4, 3, 2, 1? We have already discussed about all these. So today we will start with the three-way handshake process now. Three-way handshake process. So the thing is, what is a three-way handshake process? Actually, this process we use to start, okay, or you can start the process for opening a TCP connection. Let's consider there is a two, this is the client and this is the server. And between that, if we have to establish any TCP connection, okay, so first of all, for that, we need three-way handshake process. About the three-way handshake process for that. So in the like in interviews, they can ask you these type of questions as well. Ki, okay, why do we need three-way handshake process? Why this is required? The first thing is ki, okay, just to establish the connection. Okay, after that they can ask you again. Okay, after that, what are the like more uses? Means what are the objective actually? Objective of three-way handshake process. So first of all, you can say ki, let's say, yes. For the TCP connection establishment, we can use it. The second is initial content, okay. Actually, initial proof of existence. Existence of what? Existence of the server and the client. Okay, let's consider these are the two things, two devices or two, okay, 10.1 and 10.2. And I have to establish, I have to go with some data transformation over there, but with the help of the TCP. So first of all, three-way handshake process will be done. Okay, that is to establish the connection. But what are the main objectives for this particular three-way handshake process? So the first thing is this is actually the proof of existence. This is the proof of existence there. As an initiator, okay, I just want to know okay, on the another side, the destination site is existing or not. So just to find out, yes, just for as an you can say the proof of existence of your destination site, okay, we are using three-way handshake process. Okay, because if 10.2 is existing, so on that time only you can do the three-way handshake process. Am I right or not? Let's consider this is two devices, and you want to establish a TCP connection. So this is dot one and this is dot two, and you are trying to establish the connection with dot three. So guys, that tell me if dot three is not existing, so is that possible? Not at all. That is not possible. Okay, so mainly the three-way handshake process, okay, we use first thing just for the proof of existence. This is the first objective. Okay, the second is okay, if you are verified from here yes 10.2, if this is your destination, means yes, destination side is actually existing there. So then what is the second objective? Exchange parameters. Okay, because with the help of the three-way handshake process, guys, we exchange a lot of parameters as well. The two and the basics parameters if I'm talking about here, that is MSS, maximum segment size, and the second is MTU size, okay, or you can say window size. This thing, okay, this is almost same to same, okay, as compared to MTU, we will use MSS. This is your MSS. TCP, MSS. Okay. So MSS is what? This is maximum segment size. Okay. So overall, okay, for the TCP, we can say overall objectives. First is obviously this is the very basics you have to use. We are using it to for what? Connection establishment. The second is with the help of this thing, we will get the proof of existence. Okay. And the third is we will exchange parameters. So these are the three parameters which you can use in an interview for the answer ki, like why do we need three-way handshake process? Because this is connection oriented concept we have. So for the connection establishment, proof of the existence over there, and then exchange of the parameters. So this is the first objective of your three-way handshake process. Okay. So you have to start like this, right? These are the objectives why we need like this is a three-way handshake process in the TCP. Okay. And actually one more thing is there, you can use it like for the synchronization also. Okay. But this is not now. We will discuss this point later. Okay. Guys, after this one, this is the first thing, why do we need three-way handshake process? So this is the answer for that. The next question is, what is TCP? This is not TCP. TCP is a different thing. Okay, I'm talking about TCB here. This is transmission control blocks. Okay, this is what? Transmission control blocks. So according to the TCB, I'm talking about according to TCP, the TCP is a very important concept here. Okay. What is the meaning of and why do we need actually TCB and a connection there? What is the requirement of that? Okay. So if I'm talking about TCB always actually, it will identify your location. Let's consider, just take an example. This is your one of the browser. I'm using Google Chrome here. This is a Google Chrome, and in this Google Chrome you have already opened so many like tabs there. Just consider first is about LinkedIn. This is I'm using LinkedIn here. Next is about Twitter. Next is about Facebook. Okay. Next is about maybe your Instagram. Next is about your Cisco.com. So right now, how many tabs do we have? We have 5 tabs here. Tab number 1, tab 2, tab 3, tab 4, tab 5. 1, 2, 3, 4, and 5. So actually, if I'm talking about LinkedIn, Twitter, Facebook, Insta, and Cisco website, all these are using always HTTPS. HTTP, you can say, or HTTPS. These two protocols always uses TCP as a transport protocol. TCP protocol number 6. So guys, actually what is TCB now? Actually TCB will take care of all, like it will take care of about source IP, destination IP for this session. For each and every session, guys, each and every tab, we have different TCBs over there. So right now it means how many TCBs do we have? We have 5 TCB right now. Okay, TCB is what? It is just type of like space actually. It will allocate. TCB allocate the space for the sessions there. Okay, so let's consider if I'm talking about TCB1, which is about your LinkedIn. Okay, so it will mention actually, this TCB now contains all the information about source IP, about destination IP, about source port, about destination port, when it started, the session started at what time. Let's consider morning 11 a.m. Okay, what type of data is transformation is going on. Okay, means from your LinkedIn to the server to the LinkedIn. So like that, after that sequence number, okay, windowing number, acknowledgement number. So means so many details, like so many things are there which we have to maintain actually. Because if you remember, in TCP, we have the concept of the sequence number, if you remember guys, and we have the concept of acknowledgement number. So in our laptops, if maybe you are using laptop, mobile phone, maybe any tab, or could be any laptop also. So where all these devices are keeping all these details actually. No problem, Trimlai. Okay. So where we are keeping all these informations and all, the first question is that, okay. So guys, all these informations we are always keeping within the TCB there. Transmission control block. Okay, let's consider this is my OSI model. Okay, and this is L1 layer, L7 layer here, which is about application. And consider I'm using here LinkedIn over there. This is my L4 layer where I'm going to use, this is about the transport layer. And on the transport layer, just consider I'm using TCP. This is one of your CPU guys. This is one of your CPU. Okay. This is LinkedIn here. Now, this is LinkedIn is what? It will act as an application. This is what? This is application now. Now just consider as a client, you have to send some data towards the server and all, maybe some type of things over there. Maybe you are using some another application, could be anything. As the application, the next step is that I have to inform to my server. I have to inform to my CPU, sorry. This is the CPU of my laptop, guys. This is my laptop. This is the CPU of my laptop. This application will inform to the CPU. I have to send or I have to transfer some data. So I need one TCP. Clear? I need what? I need one TCP. This is TCP is like, let's consider you are traveling and you have to travel via flight or maybe via train or maybe via your vehicle. So first of all, you have to pack your luggage, and for that you need bags over there. Okay, so this is type of your bag. Okay, so luggage bag where we have to keep all the luggage and all. Same, this application will ask to the CPU, he can please create one TCP for me because I have to transfer the data. Then CPU will ask to the TCP, he create one TCB immediately. So then TCP will create one TCB for you. And this is about TCP. Okay. So when this application is telling to the CPU, I need one TCB. So on that time, this is a process, and this process is known as call. We have an application. This is inbuilt actually in all the devices, and that application is known as system call. This is type of APIs, guys. The system call is divided into two parts. One is about open call, and second is close call. This is about open and this is about close here. So immediately this application will use system call here, and with the help of the system call, it will ask to the CPU, please create one TCP for me because now I have to transfer the data. Is that clear or not? What is TCP? Okay, so it's in a type of luggage also. So within TCP, now one more concept come within the TCB here, and that is about socket. That is about what? That is about, guys, socket. Okay. Now, when this socket will be there, so what is actually socket? Socket always contains the four things: the source IP, destination IP, source port, and destination. These four things, guys. That's it. socket always present, okay, it will be exist actually within the TCP only. So it means first of all, application will ask to the TCP कि first of all, please create one TCP for me. First TCP for the LinkedIn. Second TCP for the, this is TCP2, which is about Facebook. And now this will be the third TCP, which is about the Twitter. This is about Twitter. So as we know already, let's consider for the LinkedIn, the IP address we are using as 11.1. For the Facebook, we are using 11.2. And Twitter, this is about 11.3. These are the destination IPs. Just consider it. So if these are the IPs there, so within the TCP, one socket will be there. What will be there? One socket. Within the socket, now four things will be there, as I just told you now: source IP, destination IP, source port, destination port. Same here again. One socket will be there, and again one socket will be there within the TCP. Voice break. No, I'm in an office, I think. What about other guys? Please try to reconnect, Harry, because right now I'm in an office and I'm getting a good bandwidth here. Please try to reconnect. So these are the now, first of all, TCP, and within that we have socket, guys. Within that we have socket. Now socket contains what? Socket contains your source IP, destination IP, source port, destination port. Source IP, destination IP, source port, destination port. Let's consider all these requests are going from the same PC. Just consider it. So now, one second. Source IP is considered 10.1. Just take an example. This is a 10.1. Destination IP for the LinkedIn, 11.1. What are the source port? Random. Let's consider 54156. And destination port is about, sorry, yeah, destination port about 443 or maybe 80 over there. Depends. 80, 443, like that. Same here, destination source IP is about 10.1. Destination IP is about 11.2 this time. Okay. Source port is about, consider 51010, and destination port is 80 or 440. Source IP is about 10.1 because from the same PC. Destination IP is about 11.3. Source port is about random port. Let's consider about 48156, and then destination port is about 80 or 440. So my TCPs are ready. So within the TCPs, we have socket concept. What we have? We have socket concept into that. Clear? So this one, okay. Now this is what? This is first of all TCP, which will allocate. This is nothing. This is just type of your space, okay. Space allocation. This is the concept of space allocation. We are allocating the space, and that concept is known as block. Okay, this is my block here. Okay, so this is the now space there, and within the space they will create then source IP, destination IP, source port, destination port, and these four things is known as about socket. Socket contains always these four things, which is about source IP, destination IP, source port, destination port, nothing else. Okay, so in interview they can ask you ki what is TCP and what is socket actually, and what is the difference between that. So TCP is what? TCP is in a type of space allocation, and your socket is about source IP, destination IP, source port, and destination. Okay, is that clear or not? What is TCP and what is this one? Good. Okay. See, right now we are going to discuss different things of the TCP there, and after that we will merge all these things there, because now I have discussed two things. Okay, three things I have discussed up to now. First, I have started with the objective. Second thing, I started with the TCP, and third, I started with the socket. Okay. Now, next thing is about three-way handshake process. If you are talking about three-way handshake process, okay, that is always we have some state concept into that. So it is divided into three parts: the first state, the second state, and the third state. The first state is known as setup. This is about setup, when your three-way handshake process is going on. This is the concept of when your three-way handshake process is going on. When it will be done, that is known as established. This is about established state. And now, after the establishment, now I can transfer the data transfer can be possible. This is about data transfer can be possible. And the third thing is about tear down. Means about close. This is means three-way handshake started. Just it started and now it's going on. Still it's going on. Okay. Data transfer means it's established and now data transfer should be happen. Okay. And once data transfer will be done, in the last we always use fin packet to close the session. Fin. So when fin will be done, after that we will be in the which state? That will be tear down. Okay, now your connection is down. Means connection is closed. This is established. This is closed. So this concept is known as about tear down. This is established. This is setup. So these are the three different states of the TCP. Is that clear? What are the TCP states? Yes, guys. Anyone? Any doubt? Okay. Next thing is, we just now discuss about TCP. Okay, what is TCP actually? Okay. So the thing is, how TCP can be happen actually? How many ways are there? How like TCP can be happen? Okay. So TCP can be happen, okay, by two ways. Very important concept in TCP. Okay. Okay. What are those things? The first thing is about active open, passive open. These two things. TCP, if I'm talking about definition, so I think this will be the best next thing over there. The TCP will maintain, TCP will maintain the information about all the connections, okay, from same server or same server, you can say, or you can say it's from client. This is known as about this. And TCP, within the TCP we have which concept? We have socket. Now what is, and now how we can create the TCPs? Okay, see, if I'm talking about, I just told you before that this is the one of the application on the L7 layer, and this TCP giving the instruction to the CPU, please create one TCP for me. And now TCP is giving the instruction to the TCP, hey TCP, create one TCP now. Okay, So the thing is ki how they can create this TCP. How many ways do we have? So to create this TCBs now, we have two ways, active open and passive open. Okay, so let's start. So just consider this is one of the application I'm talking. This is about LinkedIn application. This is the LinkedIn. This is an application. Okay. This is I'm talking about client here, guys. First we will discuss about the client and then we will discuss about the server. Actually now LinkedIn. If we are talking about active, sorry, if we are talking about active open, actually, what are the this is LinkedIn is about active. Sorry, one second. This is active open we are talking about here. Active open means कि when your CPU, when CPU or you can say TCP will create the TCB on demand. Yes. Okay. Okay. So this is on the demand only. When it's required, then it will create the TCP. Means, see, very simple. This is your laptop. Okay. And this is one of the Facebook server. So from your laptop, let's consider at the same time in a browser, how many applications or like applications I can use it. Maybe I'm using max to max 3, 4, 5, 6, 7, 8, 10, LinkedIn, maybe about Facebook. If I'm talking about right now in my this one, how many applications I'm using it right now? Can you see? One Zoom I'm using, YouTube I'm using, and hardly means 4 to 5, not more than that. LinkedIn, Facebook, YouTube, Zoom, or maybe one more. Like max to max 10 applications you are using at the same time. Not more than that. Really not possible for the client. Okay, you can use it, but that is not possible because that is at the same time you can work any of the like single application, not more than that. So the thing is, if only 10, 15 or 5 applications you are using it at the same time. Let's consider now you are going to use one more application and I'm going to use here any application which is about TeamViewer. So what is that? When I will start on TeamViewer on L7 layer, so then this TeamViewer will ask to the CPU, please create one TCP for me. Please create one TCP for me because I need TCP now. Because without TCP, that is nothing. That is not possible. Within TCP, then they will create what? They will create the one socket into that. And in socket, they will mention source IP, destination IP, source port, destination port, these 4 things. So this TCP, actually CPU is creating on demand actually. This is about on demand. If there is a no demand for the any type of TCP, so there no TCP on. No demand, no TCP. Clear? Because that is not required. But if I'm talking about any of server, could be Facebook, Insta server, on this server guys, so many requests are coming for the what? So many requests, thousands of requests are coming at the same time for the TCP connection. Okay, let's consider we are using here one, this is the Facebook server, okay, and we are using here at the port number 80 or maybe 443. So what is happening here, keep thousands of requests are coming at the same time. So if my FB, okay, because we are using so many applications on a server side also, if those applications are manually asking to the CPU, hey CPU, can you create first TCP for me? Now one more request, can you create one TCP, one more TCP for me? One more TCP, one more TCP, one more TCP, one more TCP. At the same time, let's consider if we are getting thousands of like TCP request, sync request, okay? So it means immediately at the same time, T0, the CPU, or the CPU of this server has to create 1000 TCP at the same time. So that is actually that can be possible, because that's why higher end servers and all we are using on these sites. Okay, it's not like that. Facebook, in the Facebook data center, they are using 8 GB RAM or 20 GB RAM and all like that. It's not like that. They are using higher end servers actually. So what happened actually on that time? Let's consider this is me and I'm a server, consider it. And I know that I'm a server and so many requests can come to me at the same time. And if some requests will come, I have to send reply, because if just consider at the same time, if 10 sync are coming, so I have to send what? I have to send sync plus ACK or not? I have to send. So once I have to send sync plus ACK, so immediately I have to create what? TCPs. So first of all, I have to create the TCP, and within TCP, then I will create sockets into them. And what are the sockets? Sockets will be source IP, destination IP, source port, destination port, source IP, destination IP, source port, destination port, then source IP, destination IP, source port, destination port. So as a server, I'm thinking that why I'm waiting for the request and all, because I know I'm a server and I have to reply, because I don't have any another option. I'm not gonna send sync to anyone because I'm a server. I'm not gonna send any type of sync from request from here. I'll get what? I'll receive the sync. I have to receive the sync, and then I have to send the reply as a what? Send plus active. So why? So this thing is there. So I'm thinking that if this thing I have to do it, so I'll do one thing. Before coming any request and all, I'll create some TCP in advance. Means server will ask CPU to create the TCBs in advance. Not on demand. This is not on demand, okay, not on the same time. This is what? This is an advanced gas. Okay, so on that time, as I like now, I'm thinking, okay, see, I'm a server, I don't know from where I'll get the like sync packet, because client, I'm not sure, fixed clients I don't have. It's not because I'm a Facebook server, request can come from any IP that I don't have any idea from where it will come. So once I'm using TCP, so within the TCP, I have to create socket also. It's not like that only TCP I have to create. With TCP, immediately I have to create socket also. So in the socket, the 4 things I have to mention there: source IP, destination IP, source port, destination port. So let's consider my IP is 15.1. My IP is 15.1. So what I will mention here, source IP 15.1. I'm an HTTP server or HTTPS, depends. Let's consider I'm talking about HTTP. So port number is what? 80. It's not gonna be changed. It's not like that for the one client it's 80, for the another client it will become 79. No, because I'm a what? I'm an HTTP server. So obviously, when I'll send the reply back, what will be the destination source port? That will be 80. Can you mention any destination IP here? Not at all. That's not possible. Then mention there source IP, again 15.1, source port 80. Source IP 15.1, source port 80. These things. So like that, I will create n number of TCBs in the advance only. So now my TCBs are prepared. If I'm getting any request, so let's consider I'm getting any request from 17.1 as a random port, source port as a like 54150. One more 18.1 and source port is 65111 over there. So what I will do immediately within the fractions of seconds, even it will take milliseconds over there, I'll do one thing. Key destination IP I will mention here 17.1 and I will mention here 51520. So means when I'm getting the sync over here, so on that time I have ready made, you can say I have ready TCBs already. My TCB is almost 90% it's ready. I have to just mention there IP from where it's coming and from which port it's coming. So that I will mention, and then I'll send it to the CPU and to the next device. Okay, boom, let's go now. Same here, destination IP will be 18.1 and destination port will be 6.5. Okay, so now my sockets are ready, and now I'm sending it to the destination. Clear? So this concept is known as about your passive open. So we have, let's consider this is the client, and if this is the server. Okay, and if we have to establish any TCP connection. So first of all, let's consider I'm using any A application. Okay, and this is the server at port number 80, and its IP 16.1, and this is 15.1 here. Just consider it, ISP in between that. So now if we have to establish the three-way handshake process here, so the first is what I have to send sync. So immediately this application will ask to the CPU, please create one TCP for me. This is on demand actually. And within, this is a TCP. And within that, let me create one socket also. Source IP, destination IP, source port, destination port. Source IP 15.1, destination IP 16.1, source port random, let's consider 64111, destination port 80. So this is on demand. So this is the on demand, so means this is known as active open. Okay, and this one, what server will do? Server, because this is a server has to be ready. Okay, so what is the server? The server will do one thing, okay, I'm not going for any demand and all, let me create so many TCPs, because I know I'm a server and definitely I'll get so many requests. I can get so many requests at the same time, so my TCPs are ready. So into that I will mention about source IP, source port, source IP, source port, source IP, source port, source IP, source port, because I'm aware about that 16.1, 80, 16.1, 80, 16.1, 80, 16.1, 80. I know about this thing. What about the destination IPs and all? Destination IP, destination port, destination IP, destination port, destination IP, destination port, and destination IP, destination port. These things I will configure once I'll get any sync request. So this concept, when your all the TCPs will be in the advance, that concept is known as about your passive open. Okay, so TCPs we can create in the two manners. One is about active and second is about passive. Okay, and when we are using open, what does it actually open means? Open means this is nothing, this is just type of blocks actually. This is about block we are talking about. Okay, and block, which block? We are talking about TCP block. Is that clear? And this passive open is also known as unspecified passive open. Unspecified passive open. Why we call it unspecified also? Because my destination IP and destination port we haven't specified. So this is the reason why this is also known as your unspecified passive. And opens means this is what? This is creating the block, or you can say structure, that is known as open actually. Creating structure, okay, creating the blocks and its structure, that is called as open also. But they will not ask you what is open and all, so no worry. The main thing is about active open, passive open, and this is also known as unspecified passive open concept. Okay, so passive open, you can say the definition if I'm talking about here. कि you can say कि TCP created in advance, okay, to allow capability of listening for any incoming request. So means कि my TCBs are ready, guys. Okay, just forehand like normal language if I'm talking about. Okay, I think it will be clear more. This is just taking this as example. If you are getting this example, that's good. If you will get it, active open, passive open. Passive open is like your class toppers who's always preparing 1 or 2 months before the exams there. Okay, and active open means always about one day before. Okay, now tomorrow's exams. Now let's start, guys. So one night fight. So this is about active and this is about passive. Okay, guys, is that clear or not? What is active and what is passive open? Any doubt, any question? You can ask me. I'm waiting for your questions. Yes, guys, any questions? Any doubt? What is the maximum TCP that server can create on handle? Is that any limit? Does it depend on? Yes, server resources, again, there always depends on what server you are using it. What is their resources? What are the configurations? Depends server to server. If we are comparing, let's consider I have in a server, and it has a 32 GB RAM, okay, and I have just enabled some server like specific services on that. And one is the Facebook server, and they are using RAMs and TBs and all. So that depends actually. Can't say anything. Okay, so server to server, it will vary. Yes. Okay. Yes, about other, and what about other guys? Any questions? Any doubt? From interview perspective, active open and passive open is very important. Okay. Now tell me, guys, we have one more concept here now. ISN. Identity sequence number. Sometimes we call this as a sequence number also. Okay, this is one of the 32-bit concept. How many bit? 32 bits. Now, guys, I hope you are aware about proper three-way handshake process. So let's start. Now, just consider this is one of the client. Now, this is one of the client here. This is one of the server. Okay. So if this is the client, so this is now active open. This is open, or you can say opener as well. And this is passive. Good. Now, from here, we have to send what? We have to send sequence. Oh, sorry, we have to send sync. Okay. As a reply, what we will get, guys? Send plus act. And then finally, acknowledgement will be there. What will be there? Acknowledgement will be there. One thing I just want to know, guys, do you know what is a sequence number? What is the key? In TCP, we are using we have one sequence number and acknowledgement number concept. Are you aware about that or not? Only Vinay. What about other guys? Sequence number. Sequence number, everyone. Na? Okay. So mostly actually, if let's consider this is my new connection, guys. Listen it very carefully. This is very important. Okay. Let's consider that this is your first TCP connection, which I'm going to be establishing. So the first packet we are sending, so always we are sending what? Sequence number. What is that? Sequence number. So when we are sending the first packet, what is my sequence number? 1, guys. Correct or not? Yes, guys. Correct or not? Guys, good morning. Have you done your breakfast or not? Correct? Yeah. If this is the sequence number here, after that, once the reply will come back, okay? So on that time, see, this is the sequence number of this sync packet, correct? Plus, once reply will come back, so we have now 2 packet, sync plus ACK here. So now we have 2 different sequence number this time. One is the sequence number for my sync packet, and one is the sequence number which is about my acknowledgement. This is about acknowledgement. See, for this one, I'm sending acknowledgement here, but this is I'm asking, okay, are you ready or not? This is second sync packet there. So for this one, we have one different sequence number. So when we are sending sync, after that, we will get the reply back. Okay, so in the reply, what will be there? 1 plus 1 equal to 2. 1 plus 1 equals to 2 over there. And sequence number, again, maybe it will be start from 1 because this is the sequence number of this one. Okay, I'm repeating it once more. I'm sending sync. Okay, and sync is about, let's consider sync sequence number is I'm using K. Reply will come back sync plus ACK. So for the sync, this is new sequence number. Let's consider I'm using L here. And acknowledgement will be K plus 1. Will increase by 1. When we will send reply back, okay, this is what? Final acknowledgement. So on that time, this is what? This is acknowledgement only. So this is its sequence number. It will be remain same, K plus 1, and this will become your L plus 1. Because this is your sync, this one, this is sync sequence number. So I'm not sending sync this time. I'm sending what? I'm sending acknowledgement. So which sequence number will increase? My acknowledgement sequence number will increase. So it means if I'm coming back here, this is 1, this is 2. Okay. And let's consider from there the sequence number we are getting 10, just for example. So now once we will send acknowledgement, so my sync sequence number will remain same, which is about 2, but my acknowledgement which I'm sending, that number will become 10 plus 1, and which will become yes, listen it very carefully. This is very important concept here. Okay. Repeating it once more, please listen it very carefully. If you have any doubt, just ask me. Sync, because upcoming classes will be totally depends on this concept here. Sync number is K. Getting reply back, sync plus ACK. This time, this packet actually, this segment performing the 2 things, synchronization and acknowledgement. 2 roles actually for the 2 purpose we are using it. So this is acknowledgement will before this acknowledgement for the which sync actually, guys, for this one. Okay, so obviously it will increase by 1 here. And this is a new sync which is about L. Finally, this guy is sending acknowledgement. This is about acknowledgement. So when it's sending acknowledgement, this acknowledgement is for the this one, not for the this concept. So on that time, this k plus will remain same and acknowledgement will increase by 1. L plus. This is the concept of sequence number. Okay. Is that clear or not? Yes, guys, is that clear? This is the very basics. Yes, na? Okay. Now, after this, and guys, yes, one more information. After this particular classes about TCP classes and all, I'll give you one small one test also. Okay, that will about your TCP and all. Okay, one questions I will send it to you. Then you have to go through that. Now, the next thing is key. Tell me one thing, guys. When we are using packet tracer, packet capture, sorry. When we are using packet capturing means when we are using Wireshark. So the sequence number always start 1 or not, correct? I'll show you. I have one captured packets already. And what is it that packet capturing? That is looks like between two routers. This is about 10.1, 10.2, and I have enabled here telnet. And I have pinged from here. One is for the ping and not ping, sorry, telnet. This is for the telnet and this is for SSH. So this is the LAM R1, R2, 10.1, 10.2. So I have captured packets here, telnet or SSH. I'm going to be open this one. Now, is that visible or not, guys, to everyone? Visible now? Okay. Now, this is my sync packet. See, this is sync plus add. What is the source IP? 10.1, 10.2. This is what? This is sync 10.2 to 10.1. Reply back as a sync plus add. And third is about acknowledgement. These things. Okay. Now, just 1 second. Let me do one thing. Now, when you will start your packet capturing on your PCs, on your laptops and all, this type of output you will get it. Now let's open my first packet here. When I'm opening my first packet, okay, into this one, what is the relatively sequence number it's showing? What is the sequence number it's showing? 0. Okay. So if I'm sending as a 0, so obviously reply I'll get a what? 0 plus 1, which will be 1 here, right? So if I'm going with this one, see, it started with 0. Listen it carefully, see carefully. Sync packet, when I'm sending my sync packet, what is my sequence number here? 0. So obviously in the acknowledgement for the this sequence, for the this sync, what I'm expecting? If I'm sending as a k, so k plus 1 I'm expecting here. So what is this one? 0, 0 plus 1 equals to 1. Clear or not? So can you see now in the reply, what is the sequence? See, in the sync, in the request, the sync is what? Sorry, sequence number is 0, but acknowledgement what I'm getting? 1. This is looks like this way, guys. 2 clients, 2 PCs. My sequence number I have mentioned here will start from 0. This is also sync. Okay, let's start with 0. I'm sending sync here. When I'm sending sync, my sequence number is 0. That's good. Reply coming back. When reply is coming back, sync plus act. So what will be the act? Act will be 0 plus 1 or not? Yes. Which will become 0 plus 1? 1. And what is the sync from here? This is 0 now. And in the third packet, this acknowledgement will remain same 1. And this will become what? 0 plus 1 equals to be 1. Okay. So the same thing you can see here also. SYN 0, acknowledgement 1. This is the SYN from the another side, acknowledgement number 1. Is that clear or not? Any doubt here in sequence number? This is your pack Wireshark, guys. Wireshark is not like that. We are always getting exact number for the exact output here, or means exact packet capturing. I'm doing it. If we are talking about actual corporate concepts here, or actual networks and all, so the sequence number in this example, my sequence number is starting from 0, but actually it will not start from 0, guys. This will be, it can be any random number, guys. Now, concept is clear. That's, I hope this is clear. So this concept is same, but I'm talking about here, I have mentioned, and even we are not mentioned, even we are doing the capturing. Can you see my sequence number starting from 0? But actually, guys, it will not start from 0 exactly. This, it could be any random number there, like 86 lakh something over there, 86,000 something over there, 84,000 something over there. Could be in thousand, could be million, could be billion also. Can't say anything. That will be any random number. So once you will go for the interview, they can ask you, do you know what is the concept of random number in TCP or in the sequence number? So if they are talking about any random number, so means they are talking about sequence number. Because in interview directly they will not ask you what is the sequence number. They will ask you when we are sending sync packet. So in the sync packet, it will be sent one random number. Do you have any idea what is that random number concept there? Can you explain? So guys, actually up to now we were discussing about sequence number, not about random. Okay, so on that time you will be confused. You know what is the random? I don't have any idea. But guys, random number, sequence number is same. And when they are saying random number, so random number is not gonna be start from 0. Random number could be anything. So the next question is, in packet capturing, the Wireshark is showing 0. So how it will be converted, or we will change it, or how we can capture what is exact this random number. So there is some steps which you have to follow. Guys, see, let's see where carefully sequence number and all this one, 0, 0 and 1 over here. 0 to 1, then 0 to 1. This is known as relative packet capturing, sequence packet capturing. Go to the edit, go to the preferences, click on protocol. If you want to check exact random number, click to the protocol, go down, go to the TCP protocol. TCP, relative sequence number is enabled. Please disable this thing. Once you will disable, this Wireshark is now refreshed, and can you see this is the sequence number now? This one, yes, this is your sequence number 2163754741. This is actual sequence number, and this sequence number is also known as random number. Okay, so just please check your last 4 bit. When I'm sending this synchronized sync over there, so what is the last bit here? 4741. So let me mention here, when I'm sending it, let me use the paint. 1 second. Two clients. Okay, so first of all, I'm sending sync. So when I'm sending sync, so now what is my sequence number here? And the last 4 digit I'm using it, no need to capture. This is 4741. So this is what? 4741 here. 4741. After that, we are getting reply back. So in the reply, so two things will be there. One is about sequence number for the sync, and the second will be about your acknowledgement number. So up to now, whatever we have discussed, so according to that, the sequence number, the acknowledgement number should be increased by 1. So it should be 4742 here. So if you will go to the captures, can you check what is this one? 4742. And what is the sync this time? 1076. And what is the acknowledgement for this? 1077. So this is about 1076. Okay. And once the reply will go back, okay, so on that time, what will now? Then it will be remain same 4742, and it will become 1077. So can you see into this one? Now this time during the acknowledgement, this sequence number will remain same, because sequence number here identifying you're about, it's now giving the like sign for the sync packet, not for the acknowledgement packet, because for the acknowledgement packet, what is the counter? 1077. Let me come back here. So for the sync, what is that? Sequence number. For the sync, it will be about sequence number here. And if I'm talking about acknowledgement, so that is about always ACK number. Okay. So when we are sending here sync, on that time, can you see in the first packet, is there any acknowledgement concept? No, that we don't have. Only sync packet is there. Okay. Second packet is about your sync plus ACK. Sync plus ACK here. Okay. So in this one, this is the sequence number and this is acknowledgement. And this is what? This is acknowledgement number. So this is about the sequence number here. The sequence number is about your sync packet, which is about will remain same, which is about 4742. And this is about acknowledgement number here, which is about your now 1077. This one. This is not, this is one actually, not 77. One. So this is always about random number, guys, not about 0, 1, 1, 2, 3 here. So once you will go for interview, so on that time, don't start, if they will ask you about random number, or maybe if they're asking you about the sequence numbering and all, so don't start with 0. First explain what is a random number, could be anything, there is a no limit for that, and then start your all these things. Any doubt, any question? Anyone, any questions, any doubt? No? Okay. After this, okay, so now we have discussed about one more thing is completed here. So if I'm coming back to this one, and if I'll mention here, so first of all, we started with the objective of three-way we started. Then we compare, actually note now, in the last we will mention. So now I'm done with the sequence numbering concept here. Okay, what is sequence number? Next question, how this sequence number will increase. Okay, so sequence number will increase now after three-way handshake process. Three-way handshake done, but after that also we have to send what? We have to send the data. Okay, so on that term, how it will increase. So sequence number always increase behalf of your segment length. About the segment length. Segment length, or you can say MSS. MSS means maximum segment What does it mean actually? Yesterday we have discussed about MTU, maximum transmission unit. So when we are using maximum transmission unit there, and if we are using IPv4, so now the size is about 1500. Okay, default size. This is about MTU, which is about 1500. The next question is, what is MSS? So MSS is equals to MTU minus TCP header length minus IP header length. Okay, what is my MTU here? MTU size is 1500 minus TCP header length is about 20 bytes. Okay, it can be very actually 20, 24. Okay, so it will be very actually 20 to 60, but right now I'm using 20 only. IP header 20. So now my MSS will be 1460. This is about my MSS if I'm using IPv4. If I'm using IPv6, MTU, if I'm using 1500 fast Ethernet I'm using, on that time MSS will be MTU minus TCP header length minus IP header length. So MTU is about my 1500. TCP header will be about remain same 20. This is about now 40 here because IPv6 when we are using, then we have 2 minus 40 there. So then it will become 40, 44. Clear? What is next is about in some, if you will do the Google, okay, let's do the Google and type here MSS default size, it will show you 536 bytes. But question is, but somewhere it's mentioned 1460 also. Mention this thing. Typically MTU size in the TCP for a home computer internet connection is either 576 or 1500 bytes there. This is 576. This is MTU size. I'm talking about MTU size here. So if MTU has the two possibility, one is about 576 and second is 1500. This is the minimum size actually of MTU. Two possibilities we have. So if this is about MTU, so obviously what are the MSS will be here? 576 minus 40 and 1500 minus 40 will become 4060 will become 536 here because we have two possibilities and this is for the IPv4. If I'm coming with the MSS again, but this time if I'm talking about IPv6, so 576 minus 60 here, so it will be 526 and this will be 60 minus 15, sorry 40, this one. This MSS maximum segment size is also known as segment length. Segment length, MSS, or you can say this is also known as actual data, which you have to transfer, over. That is the minimum size, Kalpana. That is the minimum size of your NEMTU, 576. So these three things we have: segment length. If I'm saying somewhere ki I'm using segment length, if I'm saying MSS, if I'm saying actual data, the concept will remain same, guys. Okay. Now, if we are talking about here, okay, now we have the concept of segment. Segment, I hope guys were aware about that. What is segment actually? Segment is what? This is a PDU, protocol data unit, which we use on L4 layer. Okay. Now, when from, if we are talking about, let's consider this is the L7 layer and this is the L4 layer. So when the data is coming from L7 to L4, actual that is data, the which PDU, where that this is known as data, but according to TCP, that is also called as stream. If some stream is coming from here, so see when your data is coming from L7, L5, L6, and one it's coming to the L4 layer, and after that L4 will convert this data into what? Into segments. Okay, so on that time in TCP we have to call it as a, if my data is coming from L7 to L4, so on that time it will convert that stream into segment. Into what? Into segment here. See, this is one of the application. This is the application which we are using, L7 layer. Okay, this application has to transfer some data, and let's consider the data is about 2000 bytes. The data size is 20,000 bytes. Consider it. So when 20,000 bytes is there, okay, this application giving the instruction to the CPU, hey CPU, please create one TCP for me. Please create one TCP for me, because I have to send what? I have to send the data. Okay, then CPU saying, okay, let me do it. Let me ask to the TCP. It will give the instruction to the TCP, please create one TCP. TCP is created, and TCP, within the TCP, one socket will be there where your all the source IP, destination IP, source port, destination port information will be there. Now, this is about your source IP, destination IP. These are the headers. Now the question is, where my data? So on L4 layer, we have some buffering concept. We have one buffer concept. We have one buffer concept. So this application will send this data, these 20,000 bytes, 20,000 bytes into the buffers there. And then when my TCP is ready, see, this is my socket. Okay, this is known as TCP. Where is this located and location and all? And after that, it will be converted into segment. Now this is known as segment. Because now the reason is, what is segment here? Because this is data which is coming from this layer, and this is this data. And now the CPU is copying of this, taking the data from here and putting into this segment here. And now this is, guys, this is my data here. And once we will add the data also into that, this concept is known as now segment actually. Segment is only about data, not about the IP addresses. Segment is always about, if we are talking about segment here, that is about, always about actual data. So the question is, from this data, from this one, okay, this one, right now one TCP data, now I have to send the data, and total, just consider 20,000 bytes of data is there. So the thing is, in this segment, how much data that I can send it, that thing is depends on your MSS. What is your MSS now? So my MSS, if we are using IPv4 with 1500 concept, so MSS is what? 1460 bytes. So from 20,000, 4060 bytes I'll use it, and I'll put it into this one. And now this is segment, and now this segment I'll send to the next one. So after 20,000, 1460 is there. So what is the balance here? It's about almost 18,000. What is that? 60, 14, 18,540. So these bytes are pending now. So for this thing, let me create one more TCP. For the next one more, and then make it segments and then send it to the next guy. So this concept is known as segment here when we are sending the data. So segment is also known as MSS, is also known as actual data. Okay, so 1460 is the size over there. This MSS negotiation always happen in three-way handshake process only. Okay, let's consider MSS, maximum segment size. Let's consider if I'm saying, guys, today this TCP session will be up to 6 p.m. So that is what, and you are saying, no, Amit, that's not going to possible because we have shift and all. Max to max, we can take it, we can stretch it up to 2 p.m. So this is what, this is your maximum segment size. I'm saying I'm going to take the session up to 6 p.m. and you are saying no, 2 p.m. and after that we will negotiate and all. Okay, so finally we decide, okay, we will make it up to 145. So this is what maximum segment size, maximum data which we can transfer actually. So let's consider this MSS negotiation. This is always negotiation will happen between both the devices there. Both them in server and client I'm talking about. Okay, this MSS negotiation will always happen in three-way handshake process. Not after that. Not after that. It will be within the your three-way handshake process only. Okay, let's consider we are doing the three-way handshake process. In the three-way handshake process, first I'm sending sync. Within that, I'm sending my sequence number. Consider any random number. Let's consider I'm taking 1 right now. Okay. After that, I'm sending MSS. My MSS is 4060 here. Max to max at the same time, I can accept this much data there. Let's consider you have to download one file from any server and server saying my MSS is 20,000 bytes. So that is not going to happen because you are a server, your configuration is too high. But let's consider I'm using mobile phone. In mobile phone, if I'll compare my mobile phone MSS with my laptop MSS, that will be different, guys, because your mobile phone doesn't have that much capability as compared to your laptop, and laptop doesn't have that much capability if I'm comparing with the server there. So on that time, maybe we are using, let's consider laptop. This is one of your mobile phone, and this is your any iPad. So different MSS here, different MSS here, different MSS. So how the server got to know what is your MSS and how I'll get to know? Let's consider all the three devices are connected with the same server. So let's consider this is saying my MS is 4060. And here my MSS is considered, let's take an example, 500, and my MSS is 750. And on the three devices, all the three devices, I have to download one file, and that file size is 5 GB there. So guys, tell me on which device my file will be download faster actually. So first of all, this is the number 1, number 2, number 3. Okay, sometimes it's happened. We are also facing this thing. Okay, I'm downloading some file, and actually now when we are downloading any file or movie or something there on mobile phone, now it's taking too much time as compared to your PCs and all. So MSS is the main concept behind that. Okay, so when in the three-way handshake process, when I'm sending MSS, actually what is MSS? MSS is maximum segment size. Okay, but actually this is the part of So this is MSS. Actually, if you remember, I'm not sure do you remember or not, if I'm going back with the TCP header, TCP header. So in TCP header, we have an option. Can you see? That is about this option there. Can you see this option? Can you see this one? So when we are using MSS, so its size will be 4 byte here. 4 byte. Okay. Listen it very carefully. I'm repeating it again. This MSS negotiation will be happen just within your three-way handshake process. And once your three-way handshake process will decide ki, okay, your MSS size is 40, 60, 500, 200, 1000, 2000, 3000, doesn't matter. So after that, it's not gonna be changed. Okay. So now when we are sending to MSS, we are sending, and this is your option actually. Optional part. So when we are sending this optional part, first of all, my header length is what? 20 byte TCP header length plus extra MSS we are using about the 4 byte. In the starting, yesterday also we have discussed that TCP header length always vary from 20 to 60 there, depends on their options, which option are you using it. So now it's in a time in the three-way handshake process, we are using one option and that option is called as MSS. So when we are using MSS or MSS negotiation is happening, so on that time, the size will be 4 byte. So then it will become 20 plus 4, which will be 24 bytes. I'll show you. Sync header length 24 bytes. This is the sync packet. Okay. This is a sync packet here, guys. And sync SYN. And what is the header length? 24 bytes. Okay. What is the segment length right now? That is 0. What is the meaning of segment length? Segment length, I told you, this is data, nothing else. So right now, we are not sending any data in the sync packet. Sync packet is what? Synchronization is happening here. I'm repeating it again. Don't be confused. I'm saying TCP segment length is about data. But right now, because when your data transfer will be start, guys, data transformation will be start after when your three-way handshake process will be decided. Okay, now this is established. Here I'm sending ki, hey, my MSS size is 4060. This saying, okay, 4060. Let's do it. Okay, let's go with the 4060. Now 4060. This is the maximum size, maximum data ki in a single segment you can send. Now depends after that ki when you will send now. Connection established. Now data transfer will be start here. So now when your data transfer will be started in my first segment, if I'm sending, let's consider in the first segment, I'm sending my 1000 bytes there. Okay. So then this concept will become on that time. Your segment length will be 1000. So right now my segment length is what? 0, because right now I'm not sending any data. Right now synchronization is happening here. I'm just telling to the server ki my MSS size is 4060, and where I'm telling that thing, minimize this thing, come down. Can you see options here? Can you see option here? What is the option size? 4 byte. Maximum segment length size, MSS 4060. Clear? This is right now what is happening. This is just your synchronization is happening. Sync is happening between both the devices. This is the packet number 1. Let me come back with the packet number 2. Option maximum sequence. Now this is what? This is about 4060. Clear? Header length C 24 byte only. And when I'm talking about acknowledgement, okay, so this is what? See, this is 20. Because in my first and second packet only, the synchronization between the MSS will be happen. I'm sending 4060. This is also sending 4060. Okay, then bro, I can accept 4060. This is saying, okay, I'll send you 4060 only. Don't worry about that. And now final acknowledgement, packet is about 20 bytes. Because now after that, there is a no MSS concept. Okay, so can you see what is this segment length, TCP segment length? Still it's 0 because this is not the data. This is still synchronization is happening. And but if I'm coming with after that, this is the data, telnet data. Click on this one. Can you see segment length is what? 9 now. So means how many bytes am I sending right now? Am I sending 9 bytes into that? Is that clear? I'm sending how many bytes? I'm sending 9. Negotiation is already happened. And can you see, is there any option field there now? No. After flag, sequence acknowledgement analysis. And after that, this is the data, guys. This is the data, 9 byte. And this. Is there any option field there after this one? No. But in 3-way, that was there. Even in the 3-way, if I'm talking about that, even in the acknowledgement, that was not there. That option concept was only in your sync packet. That is about options. Clear? This is optional, not the mandatory concept. Okay, so this is telnet, and now segment length is what? 9. This segment length is also known as, one more thing there, byte in flight. Yes, byte in flight there. In exam, they can ask you, what is the meaning of byte in flight? When I'm sending the data from one client to another client, or when my segment is ready and now I just push this segment key go, and now it's coming here and I'm sending the data what? 9 bytes here. Okay, so when this is going here like this way, so this concept is known as your data in flight. Sorry, bytes in flight. Is that clear or not? Okay, so I think guys, for the day it's done, and this is sufficient also. So please go through this video again if you are clear. Very good. Still, if you have doubts and also, better thing is that to go with that, because tomorrow what we have to discuss, ki, okay, 40-60, this is we decided ki, okay, we are just deciding this thing. But after that, how much data, how your CPU is using the data and all, how they are sending and all, okay, how they are, how they deals with the sequence number, how it will be varies and all these things, and Nagel algorithms and all, we will discuss tomorrow. So for the day, it's done from my side. If you have any question, if you have any doubt, so you can ask me. So otherwise, it's done for the day. Send me your email IDs. I have your email IDs. Yeah, I'll give it today. No worry. Okay. Today I'll send you all this access and all. So I hope this lecture was it will be like beneficial for you. Okay. Otherwise, depends. If you all know already these things, so that's good. Otherwise, up to you. Okay. So I'll try to cover TCP as much as like in depth, what is possible for me. Okay. Otherwise, yes, we will start with the next classes also. Let's see. So thank you for the day. See you tomorrow, the same time. Take care. Bye-bye. The video I will share within the next 15 minutes. Okay. Then you can download it. Okay, guys. Bye-bye. Take care.